your notes out as well, but I want your yellow sheets out because some of this stuff you took notes on your yellow sheet. Yeah. So, when I say limacons, what shape is in your head?
A Y. Like a typical.
Say they're ovalish, but sometimes it has a loop, sometimes it looks like kind of a heart, sometimes it looks like a squished oval. Okay? There's actually 4 different kinds. Alright? So first of all, up here, this tells us, hey, it's a limacon.
What?
Hold on. Wait for it. Wait for it.
What?
Okay, this up here, this gives us, hey, it's a limacon. Okay? Woo! Alright, what does sine or cosine determine? Okay, the direction and the symmetry. Okay, we talked about it yesterday. Anything with a cosine has what kind of symmetry? Horizontal. Anything with sine has vertical. Okay? This, plus or minus, what does it determine? Okay. The direction that it opens. Okay? I'm going to say opens. I understand that this is a closed figure. Okay? But I just, the simplest way to describe it, okay? So let's go down here. You took notes, or you were supposed to take notes on which direction these limacons are going to go. Okay? So would you like to talk about the sine or cosine ones first? Cosine. So we either have a plus b cosine theta or a minus b cosine theta. Now these are going to be symmetric about the horizontal axis, so they're either going to quote unquote open. Which way? Okay, so either to the right or to the left. Okay? Now they're going to be on both sides of the pole, but a majority of the graph is going to be on one side or the other. So if we have addition, where is the majority of our graph? On the right. If we have subtraction, a majority of the graph is left. Okay, now if we have a sign thrown in there, that means a majority of the graph is going to be either up or down from the pole. If we have addition, it's going to be up. If we have subtraction, down. Similar to our circle rules, correct? Yeah. All right. Let's go back up to here. What did you figure out about a plus b? Well, it has something to do with r. What do you mean by size? Okay, I wouldn't say how big it is, but it has something to do with, okay, what is the second thing I made you fill out on your worksheet yesterday? Max R value, okay? With our roses, that was the length of the petals. Okay, A plus B. Nice pickup on my hand. Max R value, okay? A plus B is going to be our longest distance from the pole. Or it's going to be the distance that we're opening from the pole. Is it opening right? Is it opening left, up, or down? That distance is going to be determined by A plus B. Okay? As we graph these, okay, I hope that you will see why. As you played around with them in your calculator, did anybody pick up on that? Okay. I was thinking that more of you would pick up on the A plus B when you're using these in your calculator. What? Okay, let's go down here. Cosine of 0 is 1, so we would have A plus B, right? Cosine values oscillate between what? -1 and 1, okay? So when this is 1, that's the biggest it's going to be, because that's the biggest value this one can be, okay? Alright? Which is why this one opens to the right. Okay? Now, let's talk about this one. Why this one opens up. Okay? When is sine equal to 1? At pi over 2, so you have that max distance at that 90-degree angle. That's why it's opening up. Okay? Alright, now, A over B. Okay, good. The type that we have. Now, did anybody figure out, well, you were supposed to take notes on the different types. Did you see the 4 pictures in your book? Okay. So, this pretty loop-de-loop. What is this called? Okay? We're just going to say it's a lemicon, and then you're going to put next to it a loop. Okay? Make B. How do we know it's a loop? Write it down. No? Carl, write it down. This means A over B is less than 1. When you do the ratio, it is less than 1. This second one, what is it called? Cardioid. Sounds a lot like what? Something that deals with a heart. Kind of looks like a heart.
Cardiac.
Okay. When A over B equals 1, what does that mean about A and B? We're going to say, very good. Okay. The third one, what is this called? Dimple. Okay? It's basically an ovalish shape with just a little poke, right? It almost looks like a cardioid, but what's the difference? It does not hit the pole. Okay? A cardioid, the heart comes together at the pole. Okay, the dimple is at the pole. And a dimpled, we don't hit the pole at all. Okay? And then the last, how do we know it's dimpled? A over B is bigger than 1, but less than 2.
Yeah.
Strictly less than 2. Right? Because then our fourth one is called convex. Okay? And even if you didn't take notes, the most obvious observation for A over B, greater than or equal to 2. All right. Now, when you learn the order of operations, you learn, please excuse my dear Aunt Sally. Okay? That helps you remember it, right? I will give you something to help you remember these in order. Okay? You notice how your A over B ratios go in order here. Okay. So as long as you can remember the ratios, okay, basically of 1 and 2, right? So remember. I'm going to talk about Lou here, alright? Lou loves for the heart, dimpled cuties. Okay? Lou for Luke, loves for the heart, cardioid, dimpled cuties. If you want to make that chicks, because that's what you'll remember easier. Okay, so if you need that to help you remember, because you are going to have to classify the type, and you need to know what type it is so you can actually draw it. Okay? Now, what's nice about limacons is we really only have to worry about 4 significant terms. Oh, good. Okay? Did anybody look at A minus B? Okay. We'll do an example and maybe you can, yes, figure it out. First one. Okay, so we know right away this is a limacon. What is A?
2.
What is B?
3.
How does that compare?
That's the 1.
Which means this is a... Hey. What is our max auto value? 5, because you add A and B together. Alright? Now, we always start by plugging in. Thank you. Where is the majority of this graph going to be placed? To the right of the pole. Very good. Now with limacons, our easiest values are going to be at the axis. Okay, so we're going to start by plugging in 0. What do we get? 5. Then we're going to plug in pi over 2. Well, what's cosine of pi over 2? 0, so we're left with 2. Alright? Then, we're going to plug in pi. What's the cosine of pi? -1. So we have 2 minus 3. Okay? So where is that? Here's pi, right? And we have to go backwards 1. Ah, that's where our loop is. Very good. Next, 3 pi over 2. Well, what's the cosine of 3 pi over 2? 0. So we just get 2. Because, so here's 3 pi over 2. And we go out 2. Okay. That needs to be negative. And then finally at 2 pi, we have 5. Should get us back to where we started, right? Okay. Now we know this is a loop. So we know, here's where we start. We're going to go through this guy. We know it has to go through the pole to make our loop. How many times did we hit the pole?
Twice.
So how many zeros?
5.
We have 2 zeros. Now why would I not make you sign them? Okay. Okay. If I plug in 0, then I would subtract the 2 and divide by 3. It's not always a nice unit circle value, and this is a non-calculator quiz and test. So, that's fine. Okay. All right. Anybody have an observation about A minus B yet? Yes. Oh, the loop is at -1, isn't it? What's A minus B? -1. Okay. Keep that in mind. Next one. Okay, now, I guess before we go on, for the rows and the circles, I said 2 or 3 significant points is fine. For our limacons, I want all of the axes, because that's how you did the shape. Okay? Okay. Shape. Limacon, A over B is, so it is a,
Gosh, Jesse.
it's not a loop, sorry. I got distracted. What is it?
Cardioid.
It's a cardioid.
Amateurs.
It's gonna look like a heart, like the blue love. Okay, so here we go. Our max R value. Okay, so what I'm gonna do, yes, because what does the negative tell us? Okay, since this is sine, it's going to be a majority up or down from the pole. The negative is just telling us a majority that's going to be below the pole. Okay? Right. If you want to think of it like that, yeah. Okay? So now, my max R value is 8, and I only have 5 concentric circles here, so I'm going to count by 2. Alright? So I'm going to make that little note right here. I'm going to count by 2. It's okay to do that. Alright? If you need to. So when I plug in 0, sine of 0 is?
0.
So we're left R is?
4.
Pi over 2.
1.
So sine of pi over 2 is 1. We have 4 minus 4 times 1 is? Okay. At pi, what's the sine of pi? Lower left is 4. 3 pi over 2. What's the sign of 3 pi over 2? -1. So we have 4 minus 4 times -1. Oh, we better get 8, right? And then 2 pi brings us back to... So, okay, remember we need to know how many zeros we have. This is a cardioid. We start here, so we make kind of a little heart shape here. Right? I should have made this red. There we go. Alright, how many zeros do we have? 1. And we actually know what our 0 is. What is our 0?
Pi over 2.
Pi over 2. Okay. This is the only time where we can actually find the 0 without our calculator every single time, but you don't need to worry about that. Okay? What's A minus B here? 0. Okay. Next one.
Wow. Yes. Well, then you get 1.
Okay, so we have a limacon. What is A over B? 4/3. And how does that compare?
Less than 2, but greater than 1.
Okay, it's between 1 and 2, so we are dimpled. Okay, and that's our value we get from 7 because it's A plus B, right? Now, we know the number of zeros without actually making the graph.
0. 0, 0.
We're not going to touch the 4 with the last two, with a dimpled or a convex. Okay? So here we go. Where is the majority of our graph going to be? To the left of the pole, because we have cosine and there's the A minus B. Alright? So when we plug in 0, cosine of 0 is? Okay, so we have 4 minus 3 times 1. Ooh, I should probably count by 2s again, huh? I'm going to count by 2. Okay? Pi over 2. Cosine of pi over 2 is what? 0. So 4 minus 3 times 0. Okay? Next, we'll plug in pi. Cosine of pi is -1, so 4 minus 3 times -1. Okay? 3 pi over 2 is going to give us 4. And 2 pi should bring us back to 1. So, this is going to look similar to a cardioid, except the indent is just not as extreme. Okay? And obviously, we don't hit the pole. Yes? That does have an effect, because here we're taking, like in this case, it was A minus B. This was just A. This was A plus B. This was just A. Okay, because you're either adding or subtracting B or 0. So yeah, it's going to have that effect. Okay? What's A minus B in this case? 1. That's where what? Where our dimple is, right? Okay. That's one. Okay, we know it's a limacon. And A over B is 5/2, which is bigger than or equal to 2, so it is convex. You guys already assumed, right, before I switch slides. What's our max R value? 7. All right.
No zeros. Sorry about that.
No zeros? Okay. When we plug in 0, we get 7. I'm going to count by 2s again. 5/2. 3, no, 5. 3. 3 5/2. And 2 pi takes us back. 7. Okay, so this doesn't really have a dimple. It's just kind of flat. All right. What's A minus B here? 3. What does A minus B correspond to? Where the flat spot is. Okay, so okay, A minus B here is where the loop was. A minus B here, where the indent is. A minus B here, where the indent or their dimple is. A minus B here, our flat part. Okay, so A plus B and A minus B will always be on the same axis. Right? Okay? But really, as long as you plug in 0, pi over 2, pi, 3 pi over 2, 2 pi, get your shit. No matter what.